Yeah, hello everybody, back again to the last podcast of this week where we just go through the remaining parts of this introductory section. So we talked about clustering and classification, actually the methods we reviewed in KDD1, and now we have a short outlook on regression. We also talked about regression KDD1, and regression is very similar to classification. So again, you have training data and you want to come up with a model or a set of rules to classify unknown data. But in that case of regression, the output is continuous rather than categorical. In classification, it's categorical. In regression, it's continuous. Yeah, so you see here, for example, the x-axis is the input, so the actual observations, and you want to predict the value on the y-axis, which is the output. So that's why also regression is called an input-output problem, or patterns. The patterns is the input-output relationship. So in that case, it's a linear relationship, yeah, which is the most simple model again. But in general, we want to model this relationship between the inputs, here the x-axis, and the outputs, which is the value we want to predict. And the input can be, of course, much more than one-dimensional, because yeah, if you have a d-dimensional space, then the input, of course, is d-dimensional. Yeah, and you can imagine that, again, even though we know something about the data before, we have some training data, we still have to do a lot of assumptions about the type of the relationship between input-output. So for example, is it linear like here, or is it something like a parabola or whatever? So this is obviously the non-linear, and so on and so on. And that's why, again, there are a lot of different methods here. So maybe the most popular methods is linear regression, followed by some nonlinear variants like polynomial regression, piecewise linear regression. And you can also do logistic regression, which is actually a classifier, because logistic regression is has categorical output. So logistic regression is a kind of linear classifier. So logistic regression falls under the section of linear models, linear classifiers. Then we have frequent patterns and association rules. So this is the most simple way of unsupervised learning. Again, unsupervised learning, so we don't know anything about it, about the data, and what we want to know is which objects or which values and value combinations appear frequently in the data, for example, exceeds a given threshold. Yeah, so the objects we count are values or value combinations, or even substructures in graphs or something like that. You can we will see different instantiations of this problem here in KDD2 actually. Yeah, so here on the right hand side is the traditional or the first approach of frequent item set mining, where you want to see, so here are transactions of customers, and you want to find out which items have been bought together frequently. Yeah? So you see milk has been bought frequently, butter and butter together, and also sugar, milk, sugar, sorry, have been bought together 4 of 5 times. So this might be a very interesting pattern, because it suggests that there is some kind of correlation between these value combination, or these values actually. Yeah, so that's why you try to find these frequent values or value combinations. So it's the simplest kind of pattern. You just count frequencies. It's more or less a counting problem, but the search space is extremely huge, so it grows exponentially with the number of objects, the number of items, for example. So there are different algorithmic strategies, search strategies, typically based on monotonicity properties of these count values. So you count, and the counts are monotonic. And there are different ways to search for value combinations that have a count higher than a given threshold. So depth first, breadth first algorithms we had that in KDD1. Okay, so those are frequent patterns, and if you have frequent patterns, you can use those frequent patterns to generate so-called association rules, which are a kind of if-then rules. So you want to find rules like if someone or many people, many customers bought X, then also they bought Y. Here's the famous example of the Walmart data. Walmart found out in the 1980s already that customers who buy diapers frequently also buy beer. Yeah, and this is a rule: buys diapers, buys beer, and that should have a minimum support. So it should be supported by many customers, many transactions, and should have a minimum confidence threshold. So a given percentage of those that bought diapers also buy beer. This is the confidence actually, and that should also exceed a threshold. And association rule mining or rules can be derived from frequent item sets. So frequent item sets are a kind of pre-processing step to association rules. And we have to take care about confidence because there may be negatively correlated item sets where confidence is a little bit misleading. So we talked about also that in KDD1 that confidence alone is maybe not the best measure to evaluate the interestingness of association rules. Just keep that in mind. Okay, and the last class of methods we got to know in KDD1 are outlier detection methods. So here is the pattern that we look for abnormal objects. We had this discussion or this definition of Hawkins, which is kind of fuzzy and not really constructive definition, but it's better than nothing. Outlier is an observation which deviates so much from the other observations that it arises suspicion it has been generated by a different mechanism. And we had this illustration of this case, Mr. Hallam versus Mrs. Hallam, where Mrs. Hallam gave birth to a child 10 weeks after Mr. Hallam's, or what was it? 50 weeks after Mr. Hallam left for military service, and the usual gestation period is 40 weeks. So, the statistical point of view was that this is the normal mechanism, and the observation of Mrs. Hallam is deviates so strongly from the normal observations, which are those here in blue, such that it arises suspicion to be generated by some different mechanism, which is a very technical term of betrayal. But anyway, so that would the red one here would be the different mechanism, which just started 10 weeks after Mr. Hallam left for military service. So Mr. Hallam, it can't be Mr. Hallam, but anyway. So outlier detection again is usually unsupervised. If you have labels, it's supervised, but usually then very unbalanced. But in the very general case, it's unsupervised. So you don't have any labels about outliers and non-outliers. And again, then that means you don't have any information about the characteristics of the processes involved, especially in the outlier processes. And that's again why there are so many different approaches based on very different assumptions about these characteristics. So like clustering, keep that in mind, that there may be a lot of different approaches which are basically searching algorithms. If you wonder that there is some background noise here, we have a thunderstorm actually right now coming over our house, so I hope it's not really disturbing you here. I'm sorry for that.